So today we're talking about it, the temporal crescent. And it's just like the name sounds, it's a crescent of temporal field in the temporal portion of your visual field. So as you know, the visual fields are often drawn as a circle, but really they're ovals. And what that means is the temporal field is actually slightly bigger than the nasal field. And it's bigger by exactly this amount, 30 degrees from about 60 degrees to about 90 degrees. This portion of your field, the temporal crescent, is monocular. And you can test that on yourself by just putting your finger out in your temporal field and looking straight ahead. And if you cover the ipsilateral eye, your finger will disappear because the contralateral eye's nasal field cannot reach all the way to the temporal crescent. And so this portion of your field in both eyes is monocular. And so when we have the two fields, the overlapping portion, nasal and temporal from each eye, does not overlap with this temporal crescent. And that means you only have binocular vision from about here to here. Out here is monocular. Now what's interesting about this is in the traditional drawing of the afferent pathway, you have the eyeballs, the optic nerves, the chiasm, the optic tract, and the radiations to the occipital cortex. You should know that this portion of your field, this temporal crescent, is represented in the occipital cortex in the most anterior portion of the calcarine cortex. And because it's temporal field, it's actually the nasal fiber. So if the left occipital cortex has the monocular temporal crescent from the right eye. So the right eye nasal fiber goes all the way to the left occipital cortex. And what that means is when you have a visual field defect, that's a homonymous hemianopsia, you know that in this example, the left homonymous hemianopsia, the lesion is somewhere behind the optic chiasm on the contralateral side. But you cannot tell whether it's the optic tract, the geniculate, the radiations, or the cortex. And so this monocular temporal crescent provides localizing information that would suggest it is in the occipital cortex. And the two ways it can come about are if you have sparing of this temporal crescent. And unfortunately, when we do the Humphrey visual field, either the 30 degree or the 24 degree field, it only tests 30 degrees or 24 degrees. And so if you have a homonymous hemianopsia that's complete, you really can't measure the field 60 degrees out with a Humphrey visual field 30. And so you have to put your finger in there to see if the temporal crescent is spared. So in this example, this is the seeing field. We put our finger in the seeing field, yes, 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 no, 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 no. Then all of a sudden, yes again, because that temporal crescent is spared in this particular homonymous hemianopsia. And if we have sparing of this temporal crescent, we know that the lesion is sparing this anterior portion of the calcarine cortex on the contralateral side. So the temporal crescent has localizing value. In addition, rarely you can have a lesion that just is right here in this location, and that means you will not have a homonymous hemianopsia, you'll have a full field, but they'll have this monocular temporal crescent. So on a Humphrey visual field, even though the patient is complaining about a field defect temporally, when you do the field, it's normal. And there's no RAPD because the defect's in the occipital cortex, which is behind the pupil pathway. And the fundus is normal. So, and their acuity is 20/20, so you're going to think they're faking. Because they're 20/20, they have no RAPD, they have a normal exam. You did a field in a person who has a field defect, but you didn't detect that field defect because you only did a 30 degree or 24 degree field, and their field defect is actually way out here, the temporal crescent. And worse, you won't do the study they need to have, which is they need to have a scan to look right there in the contralateral occipital cortex. So you need to know about the temporal crescent. It is a monocular field defect in the temporal portion of the temporal field. It is crescentic in shape, 60 to 90 degrees. It is not in your binocular field. It is monocularly represented because it's the temporal field. That's the nasal fiber. The nasal fiber goes to the contralateral anterior portion of the calcarine cortex on the other side. And that means you can have a homonymous hemianopsia that either spares or involves just the temporal crescent, and that localizes to the occipital cortex.